Hello, welcome at Disruptive Online. In this episode we're going to show you how to set up Modbus Master with Nuttx. So here we have our Nuttx, and I've got a little cold, so maybe my voice is a little deep. So I'm sorry for that. So I built the project, and we go to make menu config, and here we have make new config, and let's see what we have to change here. At first we go into build setup, and we are looking at the host platform is Linux. Debug options, I only have generate debug symbols, and optimization level I use suppress optimization, so you can change that if you want to. The system type, let's see here, this is the chip, that's good, and we have a peripheral support, and in this case we are activating two USARTs, so one for RS485 and the other one for the shell. So we exit there, and let's see USART configuration here. We are enabling the RS485 on USART, and we are placing the polarity pin on USART on 1. And the serial driver configuration, we did not activate anything, so we leave it at that. We exit, take a look if we need some more here. We do not, so we exit again. Then board selection, let's see here, nothing to do here. RTOS, let's look at RTOS hooks, and on this board we are activating or enabling the late initialization, because then it will get bring up activated. So there is another way, but in this video we do it this way. Let's see something here. No. Then the device drivers, we need the serial driver support, and we use out in this video, we place it on a 96100 up at 9600 baud rate. We place no parity, and we don't use stop bits, and we activate the USART RTS flow control. Actually, on the STM32s they have changed the hardware RTS, so maybe we can test it later. If we disable this, what's happening? Because the RTS indirection pin, we place it on a different GPO. So let's leave it here. USART 2 is just like shell, and we exit here again, and nothing more to do here, so exit again. Then we go to application configuration, and first we are going to Modbus, free Modbus, and we are enabling the Modbus Master support and the Modbus RTU. That's over serial, so not TCP/IP but RTU. And the total number of slaves can be up to 16. We place a convert delay and a response timeout value, and I activated one callback on a holding registers and one write to single register, and I added that in the code to use in this video. So you need callback functions in Modbus. There is documentation about it, so I hope it's clear for you, and otherwise just ask some questions. You know how to find me, and Nuttx, so you can ask it there also. And I just want to thank Alan and Vitas for their support. So thanks again, guys. Let's exit here and we go to examples. And there we have a Modbus Master example. Priority master port, we use that one. The same baud rate, the parity, same. Slave address, we use 1. You can give it another number if you want. And on holding register address to query, and we only query from 1. So, and then we read 10 counts to perform. So all is set for Modbus. So let's exit, save our config, exit, and exit again. When we did this, we are going to make and build our config, and we are burning it or flashing it in our nucleo. So when we did that, when we are doing that, I'm going to show you that this setting in the board points H file, this was crucial to get Modbus working on the STM-F411. So don't forget this, because without it, it won't work. Let's see. We have a slave with some values and registers in the holding registers. And if we do Modbus Master on our, just first reset our nucleo. The first time we run it, we have 0 reading because it's initializing the buffers. And the second time, then it will read all the values like it's supposed to. And 1 is 0. Let's see. 153. This value is actually 0 because that's in the code. I have to change that, but it's registered 0 and not 1. So I made a mistake there, I see now. Then you have 150, 3, 4, etc., etc. And if you change the values, and read it again, the first time it's not reading it, and the second time it does. And there you have your changed value. So this is working. And if we go to Modbus Master, let's look at this. The holding starts and the input starts at 0, so maybe I have to change that. And there's also some code in Modbus Master main, which is reading not from n plus 0 plus 1. So I have to look at this, but you get the idea. Let's see. Oh yeah, we have that's what I want to show you. We have a method or a call, and that's a request write holding register, and we are writing like our slave address 1, and the US register address is 1, and that's always plus 1. So in Modbus this is plus 1. So if we do this, and we save it and we build it, so it's built, then we are going to flash it like this. And let's see where our terminal is. Here it is. Then we reset our board. The first time we read it, it's a 0 again, and then the second time it will read 450 because that's what I added to it. So if you change this value to 100, you see that immediately it will change the value and the second time you read it, it also will read 450. First, so it's very fast in changing a register, and well, I think in this case, this shows how Modbus Master is working in Nuttx, and maybe because it's because of my little flu here that I missed that 0, but again, excuse for that, but I think the picture will, or you get a picture, so I hope I will see you in the next video where I will show you also the Modbus slave. Thank you for watching Disruptive Online, and I hope I will see you again. You can find us at these on these places, and you know already if you saw more videos by us. So see you again until next time. Thank you.